Section 4.3, we are now going to move into t-tests. And the first t-test we are going to learn about is the confidence interval. So calculating confidence intervals, a student's t is used to compare results from different experiments. So we evaluate the probability that an observed experimental result agrees with a known value. So typically, you will have a true value to compare everything to. You will get a set of data with a mean and a standard deviation, and you will see, okay, is that known value falling in between the confidence interval? If it falls within the confidence interval, then it is not significantly different. If it falls outside the confidence interval, it is significantly different. So if we were to repeat the end measurements many times and compute mean and standard deviation, the 95% confidence interval would include the true population mean, whose value we do not know, and 95% of the sets of measurements. So you'll start seeing these numbers. This just tells you like what percentage is, out of 95% of the measurements, what's the probability. And there is a new table called the t-table, and typically they'll say, answer this confidence interval at 50% confidence level or 90%. So just make sure that you're double checking. If they don't provide that information, we will always assume 95%. So we are 95% confident that the true mean lies within the confidence interval. Here's an example of a t-table. So on the left-hand side, we have degrees of freedom. Unlike the F table where you have two different sets of data, for a confidence interval, you technically only have one set. So you will find the degrees of freedom on that particular set. And then the hard part is just finding it based on the rest of it. So typically the question will give you finding it at a specific confidence level, which is these top numbers. If they don't tell you that, you will always assume 95, and that is why it's a different color. So most of the time we're doing it at the 95, unless they explicitly say at 50, 90, or above. You'll notice that it gets easier to have a passing t-test as the percentage of data gets closer to 100. Let's practice. The carbohydrate content in a glycoprotein, a protein with sugars attached to it, is found to be 12.6, 11.9, 13.0, 12.7, and 12.5% in replicate analyses. Find the 50% and 90% confidence interval. So the first thing you want to do here is find the mean, the standard deviation, and do the rest of it. So I'm going to type things into my calculator and then, of course, just write my mean. You might have to start there. It's not going to be as quick as this. Mean will be 12.54, and I'm not rounding too soon here. Like, you can certainly round this to be 12.5, but I tend to do, like, I'll add an extra digit and round at the very end. And then the number of measurements is 1, 2, 3, 4, 5, and I will always add in DOF. So n minus 1, 4. Confidence interval is going to be mean plus or minus TS divided by square root of n. So we have everything except the t. For the t, we're going to have to go to the table, and then it specifically says at the 50% and 90%. So we'll find the degrees of freedom at 4 for 50 and 90, and then come back to this. So once again, our degrees of freedom was 4, and then it asked for 50% and 90%. So where I'm getting the t values for our confidence intervals, this is where I'm getting those numbers. So let's put it all together. Let's do at the 50% confidence interval or level. So mean, which was the 12.54, plus or minus our t, 0.741 times standard deviation, you have 12.54 plus or minus 0.13. I'll repeat this process now, doing it at the 90th percent confidence level. The mean does not change, just the t. The higher the confidence level percentages, the bigger that interval will be. So as you narrow your percentages of it falling within it, that's why it will get bigger with more percentage. So you can see on this picture here, the 50th percentage is much more narrow than the 90th percentage. There are two ways that we can report our uncertainties or with the confidence interval. So on the previous slide, I'll just use the 50%, the 12.54 plus or minus 0.13. I do want to point out when you have that plus or minus, the rule of standard deviation or significant figures is that first non-zero number has to match up with the last digit of the answer. So the correct way of writing this is 12.5 plus or minus 0.1, but you're welcome to use subscripts. So option way you can do it one is write it like this, or you can do a range. So 12.54 minus 0.13, and that is 12.41. I'll do that last digit down again. And then 12.54 plus 0.13. So you can write these in two different ways. You'll be correct either one.